Assalamualaikum everyone. So now we'll look at some numerical problems for tacheometry. Now in the first problem, the statement says that an instrument station, a tacheometer, was set up at a station C. So this location, this is actually the point C, and the following readings were taken on a staff vertically held. So that means if the line of sight is horizontal, uh, so that would mean we're dealing with case one because the leveling staff is held vertically. But if the line of sight is inclined at an elevation or depression, so that would mean we are using the case two, in which it says that the leveling staff is still held vertically, but the line of sight is inclined. So calculate what we need to do is to calculate the horizontal distance CD, and this is the point D, and we need to calculate this distance from the instrument station to the leveling staff station. So this distance CD and reduced level of the point D. And we also need to calculate reduced level of this point D. So that's a point where the leveling staff is held. When the constants of instrument are 100 and 0.15, so that means the multiplying constant F4I is 100 and the additive constant is 0.15. So the data that they have given us is readings taken from the instrument station C. So both the readings are taken from the instrument station C. So the first reading is taken at the benchmark where we have an angle of depression of 5 degrees 20 minutes, and the upper here reading is 1.5, and the middle here reading is 1.8, and the lower here reading is 2.45. Actually it would be reverse. This would be the lower hair reading, this would be the middle hair reading, and this would be the upper hair reading. And the reduced level of the benchmark is given, which is 750. Now, the second set of reading is taken at the point D, where the angle is now in elevation of 8 degrees 12 minutes, and we have again the three set of readings taken at the point D. Now, usually you won't be given the figure explaining the whole thing. So just by reading the statement, you should be able to draw this by yourselves. So since both the readings are taken at an inclination, so first reading is taken at depression. So this is the horizontal line of sight when the telescope is completely horizontal, and this is the line of sight when it is inclined downwards. Similarly, horizontal line of sight, and these are the line of sights when it is inclined upwards. Now remember the equations that we use. The equation for calculating the horizontal distance d, that would give you the distance between the instrument station and the leveling staff station, and the equation for finding out the vertical distance v gives you the distance between the horizontal line of sight and the inclined line of sight at the middle here. Similarly, horizontal line of sight and the inclined line of sight at the middle here. So that would give you the vertical distance. So how we should proceed for this question is that first we should calculate the height of instrument. So we can get the height of instrument from the location of the benchmark. So had this not been at a depression, we would have just added the backside in the benchmark to get the height of the instrument. But now since it is inclined, so we'll have to use a different method. So we have the equation for finding out the vertical distance, which is the distance between the horizontal line of sight and the middle here. So for V1, we have the equation, we will calculate that. And H1 is actually the staff reading, which is given by the middle here, which is 1.8. So in the benchmark, we need to add H1, which is 1.8, plus V1 that we will calculate by the equation. So once we have the height of the instrument, we can move towards this side, and we need to calculate first the horizontal distance d, and then when we have that, we need to calculate the reduced level of this point. And we can calculate the reduced level of this point by adding in the height of the instrument the vertical distance v2, and then subtracting the middle hair foresight uh, from that value, and that will give us reduced level of the staff station. So let's see the solution. So f4i is given as 100, and f plus d, which is the additive constant, is given as 0.15. So in the first set of observations, we are going to use the equation for v1, and the equation of v1 is the one that we would choose for case 2 and the part b, where the angle is in depression. So equation of v is given by f4i into s sine square theta divided by 2 plus f plus d sine of theta. So in our case, we have this s over here and f4i, which is 100, and this s is actually the difference between the upper hair and the lower hair. So this is 1.3, and they have converted it in millimeters. Multiply by sine square theta, divide, or was it sine 2 theta? I think it's written sine square theta over here, but I think it's a typo. It's sine 2 theta. So you can correct this over here as well. This is sine 2 theta. So they have used that plus f plus d into sine of theta, and that gives you the vertical distance. Now, in the second observations, S2, which is the difference between upper here 0.25 minus lower here 0.75, and the theta 2 is in elevation 8.12. So again, using the same equation for calculating the vertical distance v2 and the horizontal distance, they have used the equation for the same case. So in case 2, when the angle is in elevation, so d is given by f4i into s cos square theta plus f plus d cos of theta. So let's see if they use the same equation. So f4i into s2 into cos square theta plus f plus d into cos of theta. So you get the horizontal distance as 147 plus 0.97. And you should also check if they should have converted this into millimeters or if they have used it as 1.3. I think they have used it as 1.3 because the answer is in meters. So you can correct this as well. And now that we have the three values, V1, this D2, and V2, we didn't have to calculate D1 because they didn't ask for it. Now that we have these, we can find out reduced level of the instrument, which is reduced level of the benchmark, plus H1 plus V1. So H1 was 1.8 and V1 we have just calculated. So in the reduced level of the benchmark, we add 1.8, which is H1, and plus we can add up V1, which we just calculated over here, and we get height of the instrument. Now, in order to calculate reduced level of the point D, like we discussed, in the height of the instrument, we had to add V2 and subtract H2. So we add V2 and subtract H2, which is 1.5, and now we have reduced level of the point D. And that's it. That's the complete solution. So that's everything that they asked for. Now let's see the next question. In the problem 2, it says that the following observations were taken with a tacheometer fitted with an analytic lens, and the staff is held vertically. So again, it could either be the case 1 and case 2. So it is in case 3. And the constant of the tacheometer is 100. So the multiplicative constant is 100. And since they haven't given you the value for additive constant, so you can assume that as 0 because it is usually 0. So the data that they have given is in this table, and what you need to calculate is the reduced level of the point B and the distance between the points A and B. So this over here is the point A, and this over here is the point B, and we need to calculate reduced level of the point B and the horizontal distance between the points A and B. So the data shows that first the instrument is stationed at the point P, which is over here, and they have taken readings at the benchmark. So this is the point of the benchmark, and we have an inclination, angle of depression of 4 degrees 20 minutes. So this shows that this is case 2 and part B of the case 2. And from here, basically what we will do is that we will calculate the height of the instrument, since the second set of reading is taken with the same height of the instrument. So using the same instrument station P, the second set of reading is taken at the staff station A, where the vertical angle is given, which is 6 degrees 30 minutes, and the staff reading is taken. So like before, this is the middle hair reading, this is the upper hair reading, and this is the lower hair reading. And they have taken the readings at the point A. After that, they have shifted the instrument to the point B, and they have taken the readings at the point A. And for that, we are also given the staff readings and the angle of inclination. In addition, they have given us height of the instrument. Now this height of the instrument is not the reduced level as shown by the values, because the reduced level of the benchmark is 255.75 and these are 1.255, 1.255 and 1.45. So these are not the reduced levels. So that means these height of the instruments are from the ground where the instrument is held to the line of the collimation. So this distance is height of the instrument. So in order to calculate reduced levels, one other way would be, uh, if you have the reduced level of the height of the instrument, you can just subtract this value to get reduced level of the point where the instrument is held. So now let's see how to proceed in this question. And the solution is also given, so I won't be going through this. I would be just explaining how to proceed, and then you can see if you can solve this. So let's see what we need to calculate. We need to calculate reduced level of the point B and the distance between the points A and B. In order to calculate the reduced level of the point B and the distances, first we have to work our way by working with the initial set of readings. So first they have placed the instrument at the point P and they have taken the first reading at the benchmark. So that means the reduced level of the benchmark is given. And in order to find out the reduced level of height of the instrument or the line of collimation or line of sight, what we will do is we will calculate this distance V1, which is the distance between the middle here and the horizontal line of sight, and H1, which is basically just the middle here reading 1.825. So like we did before, in the reduced level of the benchmark, we will add H1 and V1 and we get the height of the instrument or the reduced level of the line of sight. Now that we have it, we can calculate reduced level of the point A. So in order to do that, we will use the second set of readings. We will calculate this distance V. So this is written V1. This would be V2. And once we have V2, what we would do is that in the reduced level of the height of the instrument, which is calculated before, we will add V2, and from that we will subtract this 1.6, which is the foresight, and we will get reduced level of this point A. Now that we have reduced level of the point A, what we will do is that we will move to the next set of readings, which is taken from the point B. Now the interesting thing is we need to calculate the reduced level of this point B. Now that we are at point B, uh, first we need to calculate this new height of the instrument, which would be reduced level of the point A plus this distance, which is H3. Since the staff is held at the same location, so we have two set of readings taken at the same staff. So in the reduced level of the point A, we will add this value of H3 and then we will add in it the value V3, so that we get height of or reduced level of the line of sight. Now that we have reduced level of this line of sight, which is horizontal, from this we will subtract the height of the instrument, which is given 1.45, and we will get reduced level of this point. In order to calculate D3, use the simple equations that we have used before, and that will simply give us the horizontal distance between the point A and the point B.